right, well, we're going to continue looking at what we began talking about yesterday. That's conic sections. Remember yesterday we began looking at this idea of a right circular cone comes to a point that extends back out. And we said if you were to intersect that cone with a plane, you could take not necessarily a cross section per se, but a section of the conic. We call these conic sections, and there were technically several of these. Some of them we'd already looked at, like a point. You know, we could point, that's pretty easy. Line, or even a couple of lines could be formed through a conic. But then there were 4 new conics we're going to study in depth in this chapter. Do you remember what those are, Jamie?
Parabola, hyperbola, can't remember the other 2.
The one we looked at yesterday?
Circle.
Circle.
And ellipse.
Ellipse, good. So you got all 4 of them. Those are our 4 conic sections we're going to study in this chapter. We said all conic sections that we will study fall into a basic conic form of an equation. What is that conic form equation as you look back in your notes?
X minus s 1 squared plus y minus.
Well, if it's a circle, yes, just all conics though.
Oh, is it the a x squared plus by squared plus cx plus dy plus e plus 0?
There we go. This is our conic form of any equation. And as we change the values of a, b, c, d, and e, we change the look of the conic. For instance, if we put a 0 in, for instance, for a b, well, that would turn this into a parabola. Or a 0 for the a parabola. We put a negative in for one of these values. We get the hyperbola. We have matching values. It's a circle. We have differing values, but they're both positive or both negative. We end up with an ellipse. So all kinds of things we can do as these values change. They shift the location of the conic. All kinds of stuff we can do out of the conic form. As we discussed these conics where the plane intersects the cone, we said all these conics have distinguishing characteristics. They're all unique in their own way. They all have a uniqueness about them. The term for the uniqueness of a conic is the term
Eccentricity.
Eccentricity. With 2 C's. Eccentricity. Let me double check it. Eccentricity. Yeah, that's an R and an I. All right, eccentricity. Mixing my print and my cursive just to drive Quentin nuts. Quentin, we do hope you get feeling better very soon. Jamie was commenting that she's had to be out multiple times this year, and you have flown solo on these videos, and now she has to feel your pain for once. So we do hope you get feeling better soon. Well, we're hearing a lot of Jamie today. All right, eccentricity, and we said for a circle, its eccentricity is
1. Oh, 0.
0, because it is the perfect cross section of the right circular cone. However, if you begin to slant that plane as you intersect the conic, we begin to get more and more eccentric, more and more greater and greater eccentricity. So we said if we tilt it just a little bit, but stay within one section of the cone, we could get an ellipse. And the ellipse's eccentricity is greater than 0, but smaller than 1. If the plane were to go completely off one end of the cone, then we would end up with a...
0 to 1? Or?
Well, the eccentricity of the ellipse is between 0 and 1. But we said if we continue to tilt the plane, we're going to get a greater eccentricity. And if we tilt the plane so it goes off the end of the cone, we would end up with what shape? Parabola. And a parabola's eccentricity will always be exactly equal to 1. If we were to tilt it even more, where we could hit both sections of the cone at once with our plane, we would get a hyperbola whose eccentricity will be greater than 1. Okay, so we had all these different eccentricities. But yesterday's focus, after we kind of gave this introduction to conics, was to focus on our most basic conic of all, the least eccentric of all, if you will, and that was the circle. How do we define a circle?
The locus of all points a certain distance away from a given point.
Okay, the locus of all points that are a certain or given distance away from a given point. Of course, that given point we call the
center.
And that given distance we call the radius. So with our circle, and again, every one of these conics we're going to define in terms of a locus of points. For the circle, we had a special circle form equation. This is what you started to give me a moment ago. All circles will fit into what basic form?
X minus x 1 squared plus y minus
Perfect. And this is based, of course, on the distance formula, right? Change in x squared plus change in y squared equals distance, and then take the square root. But if we square both sides, it knocks off the radical, and it gives us a distance or radius squared. So, for instance, if I had a circle whose center was at the point -2, 4, and the circle had a radius of 7, in the circle form, Jamie, what would this equation look like?
X minus 7, right? Oh no, x minus, or plus 2 squared plus y minus 4 squared equals 49.
Perfect. Now, of course, we could go back to the conic form if we so chose, right? We could square everything and combine and get it all set equal to 0. But yeah, just in the basic circle form, we can see the center and the radius. I sometimes call this center radius form because it shows me both of them. What if I gave you this equation, x minus 3 squared plus y plus 1 squared equals 16? From that circle form or center radius form, I can see what the center is.
-3, 1.
Careful. Remember, the form calls for the negative.
So 3, -1.
3, -1 is my center. What's the radius?
4.
So, for instance, if I gave you this equation, it would be somewhat easy to graph this. If you had a compass, right? You would simply plot your center point at over 3, down 1. You would open the compass 4 units, this would be 3 here, so 4. And you could go up 4 units, over 4 units, down 4 units. And of course, it's a lot easier if you have a compass to get a perfect circle. But even freehanding, we get a sort of somewhat halfway decent sort of circle-ish thing. And a compass really, really helps. If we were graphing the circles, for our purposes, we won't graph often, though it wouldn't be a bad idea to have a compass when you return to class on Friday, Quentin. Wouldn't be bad to have a compass then, but we won't necessarily have to have that today. Let's take a look at the homework, because the homework was intended to go beyond this. I mean, I could teach a junior higher this, right? Center radius form. Now, the why and the wherefore, where it came from, might be a little deep for them, but to plug in numbers or to see numbers is easy. We want to go a step further with our study of geometry here. And on 12a, they gave you the endpoints of a diameter and asked you to get the equation of the circle. If they give you endpoints of a diameter, that doesn't fit into the circle form. What two things do we need for the circle form?
Center and radius.
Center and radius. How do we go about getting either of those if they give us endpoints of a diameter, for instance, in this case at 0, 0, and at -2, -6?
Find the midpoint and then find the distance.
Good. Find the midpoint first of all, because if these are ends of a diameter, the midpoint is the center, and so the center of your circle,
-1, -3.
-1, -3. And then you said find the radius by finding the
Distance.
from
The center to one of the endpoints.
the center to one of these two endpoints. Which endpoint?
0, 0.
0, 0. So to find the distance here, that would give me the radius. And what did you get for your distance?
Square root of 10.
The square root of 10 units. Okay, so then, if this is my center, the midpoint of the diameter, if this is my radius, in the circle form, what's the equation?
X plus 1 squared plus y plus 3 squared equals 10.
Perfect. And we do get a whole number 10 because we're squaring the radius at the end. Now, if we wanted the conic form, let's go ahead and get it in that conic form.
X squared plus 2x plus 1 plus y squared plus 6y plus 9 equals 10.
All right, and then remember the center radius form puts the squares first,
Oh, x squared plus y squared.
and then the x and then the y,
2x plus 6y.
and then the constant.
It'll cancel.
Right, it would be a 10, but this 10 cancels, so we don't have a constant. We just say equals 0. And this would be the conic form, this would be the center radius form, or the circle form of the equation. Questions on 12a? 12c, similar thing. This time, the two endpoints of the diameter are 3, -2, and 5, -4. What did you find for the center of your circle? And then what did you get for the radius of your circle?
I got 4, -3 for the midpoint, and for the radius, I got square root 2.
So in the center radius form, what is your equation?
X minus 4 squared plus y plus 3 squared equals 2.
All right, and again, if we wanted to get the conic form,
X squared minus 8x plus 16 plus y squared plus 6y plus 9.
All right, and then rearranging it.
X squared plus y squared minus 8x plus 6y plus 25.
But we're going to subtract the 2 over to get plus a 23, all equal to 0. All right, questions on this? By the way, quizzes test will indicate whether it wants the conic form or whether it's allowing you to leave it in the center radius form, but not hard to get conic form, just a little annoying. Questions on the basics of circles like we looked at yesterday. But we know a lot of things about circles from geometry, and so let's put some of that geometry knowledge to good use. She's shaking her head, Quentin. Quentin's like, yeah, I'm excited about this. This is great, man. I was sitting at home bored to tears, feeling all sick and stuff, but now that I'm getting to do some pre-calculus, I'm feeling energized and excited about life. That's good, Quentin, that's good. All right, so let's take a look at number 9. And Jamie, what's the instructions for problem number 9 there on page 230?
Tangent to the y-axis at 0, 3 passes through 2, 5.
All right, so the instructions actually say find the equation of the circle or circles having the given properties. And then for number 9, the property they said again was?
Tangent to the y-axis at 0, 3 passes through 2, 5.
Tangent to the y-axis for Quentin's benefit, we'll put this up here. Tangent to the y-axis at, you said 0, 3?
Yeah.
And passes through
2, 5.
2, 5. I find that, that's a 5, it just doesn't look much like a 5. I find that sketches are often helpful. So let's draw a quick sketch here. Let's go ahead and plot 0, 3. And it says that my circle is tangent to the y-axis at 0, 3. What does it mean for a circle to be tangent to a line, Jamie?
The radius is perpendicular.
I'm sorry?
The radius is perpendicular.
The radius is perpendicular, and also just the actual word tangent implies it
touches at one point.
Right, so what this means is, Jamie, we either have a circle tangent like this, or we have a circle tangent like this, correct? But it's tangent at 0, 3. But not only that, we know one other thing about it.
It passes through 2, 5.
It passes through 2, 5. So in that case, could the circle be on the left-hand side of the y-axis? It would not be tangent, right? You could have a circle over here that kind of went through that point, but it wouldn't be tangent anymore. So we can discount the possibility of a circle existing over here. It's got to be this circle that's tangent. So we've got this point, 2, 5, that's on the circle. We've got this point, 0, 3, that's on the circle. But Jamie, you also said that the tangent, this line that's tangent, is going to be perpendicular to a radius. So therefore, if I drew a perpendicular, at some point it would get to the center of my circle. Now this is significant because that means I know part of the coordinates of my center. What do I know about my center? If it's perpendicular to the y-axis, it's going to be parallel to the x-axis, correct? So if this is 0, 3, then this point is got to be something else 3, doesn't it? I just don't know what it is. It's x1, 3, if you will. Does that make sense? I know it's something 3 because it's tangent and therefore the radius is perpendicular. So wherever the center is, it's something 3. I know something else, though, about the center of my circle. The center is the same distance from all of these points, isn't it? So this distance from 0, 3 to x3 is the same as this distance from 2, 5 to x3. It's equidistant. So how might I find my center?
We could try making an equation. I'm not sure how it would be set up, though.
Well, if I've got two equal distances, going back to what we did in the last chapter, I could say that distance 1 equals distance 2, so the square root of
the change in x squared, change in y squared,
is equal to the square root of this change in x squared and this change in y squared, correct? Now, of course, I don't really need the square roots, though, do I? Because they're just going to cancel anyway. So normally we'd be too lazy to write all of that. So we'll just go, well, what is the change in x here, for instance?
X minus 0.
X minus 0 or just
X.
X squared. What's the change here in y?
0.
0. So just
0.
0 squared, or just X squared. That's the change. Coming over here, what's the change in X?
X minus 2.
And the change in y?
2.
2 squared, which is
4.
4. All right, so we could say that X squared is equal to
X squared minus 4x plus 4 plus 4.
all right, and what's going to happen with these two X squareds?
Cancel.
They're going to cancel anyway. Let's move the 4x over as a
Positive.
positive 4x. We'll combine the 4 and 4 to get
8.
8. And what is our X value?
2.
2. So apparently the center here is 2, 3. How far is it from 0, 3 to 2, 3?
2.
2 units. How far, by the way, is it from 2, 3 to 2, 5?
2.
So what's the radius of my circle?
2.
And those are the two things we had to know. We have to know the center. We have to know the radius to find the equation. Well, I now know the center. I now know the radius. What's the equation?
X minus 2 squared plus y minus 3 squared equals 4.
Boom. And we won't take the time to put it in the conic form. Does that make sense?
Mm-hmm.
Questions on that problem, number 9?
Mm-hmm.
All right, let's take a look at number 8. Let's look at that one now. Go and read that. What are we given? We're finding an equation of the circle, but what do we know in number 8?
That is tangent to the x-axis at 5, 0, radius 3.
Tangent to x-axis at 5, 0, and has a radius of 3. All right, now by the way, Jamie, in my circle equation, I already know part of my answer.
X 3 or is going to equal 9.
Good, the end of the equation is going to be a 9 because the radius is 3. They told me that part, so I know there's going to be a 9 at the end, but I don't know where the center is. Again, let's draw a sketch. Tangent to the x-axis at 5, 0. Well, what would a circle look like if it's tangent right here?
Just touches it once.
Touches it once, so I could put a circle
On both sides.
on either side, right? Either a circle here or a circle here. Either way, the radius is 3. Well, we also know tangent means perpendicular to radius. So if I drew a radius of 3, it'd have to be perpendicular, or a radius of 3 here would have to be perpendicular to my center point. It's very bad artwork, I know. Well, if it's tangent and the circle's above, what's the coordinates of the center?
Wait. You know it's going to be x3?
Not x3.
Oh.
5, 3, right?
Yeah.
Over 5, straight up 3. So I know it's either 5, 3, or if it's the circle down here, what are the coordinates?
5, negative 3.
5, negative 3, correct? Either way, what's going to go in this spot?
5. Oh, x minus 5.
X minus 5. Here, it could be y minus 3 or y minus negative 3. How might I show that?
Y plus u minus 3.
And there are the two circles that could be tangent to the x-axis at 5, 0 and have a radius of 3. Does that make sense? Again, just using some of that tangent knowledge we have. Let's look at number 10 now. And we're finding the equation of a circle or circles. What's the information on 10?
Use the equation of a circle to find 2 points on the y-axis, each a distance of 5 from 3, 6.
Okay, a distance of 5, that's my
Radius.
From 3, 6, that's my
Center.
So I know the equation of the circle, right? So they're actually not asking for the equation of the circle. I already know it. What is it?
X minus 3 squared plus y minus 6 squared equals 25.
Yes, there we go. All right, so this is the equation of the circle, right? You said it's got a center at 3, 6, so something like this, and has a radius of 5. So that means the circle is going to do something like that-ish, plus or minus-ish, right? Now, because of its placement, it's only over 3 units. So if the radius is 5, that radius is going to extend out here. Again, poorly drawn, but we don't trust our eyes. Which means it must intersect twice on the y-axis. The question is, what are those 2 points on the y-axis? Well, I'm finding points of intersection. So what should I set up? Anytime we want points of intersection, I need a system of equations. Good, Quentin. So I've got my first equation. That's the circle. I'm finding where it intersects the y-axis. I need the equation of the y-axis, though.
There won't be any x value.
Well, there will be, but it'll be 0. That's the equation of the y-axis, x equals 0. For every point 0, 0, 0, 1, 0, 2, 0, 3, 0, 4, 0, right? X equals 0. That's my equation. So I just need to take these 2 equations, the equation of the circle and the equation of the y-axis, and solve to get which 2 points my circle that they defined for me intersects the y-axis. Walk me through.
You can plug in the 0 for the x.
To get?
It'll be negative 3 squared, so 9 plus y squared minus 12y plus 36 equals 25.
All right, let's combine.
45.
45. And let's bring the 25 over as a negative.
20.
So y squared minus 12y plus 20 equals 0.
You could backwards pull
Okay.
y, then
Question you keep asking yourself.
it'll be 10 and 2, and they'll both be negative. So then y will be positive 10 or positive 2.
Okay, so what are the 2 points where my circle crosses the y-axis?
It'll be 0, 10, 0, 2.
There we go. Does that make sense? Questions on that problem? Let's take a look at example 2 now, if you would. Kind of flip back a page. Page 229. Go ahead and read the example problem.
Find the equation of a circle passing through 0, 0, and having intercepts 10, 0, and 0, negative 6.
Now this takes an interesting geometry concept. We haven't looked at it in a little while. If the circle passes through 0, 0, and passes through 10, 0, and passes through 0, negative 6, then as they show, those 3 intercepts to pass through, you understand that's going to give us a right angle inside my poorly drawn circle. Anytime a right angle is inscribed in a circle, remember, an inscribed angle equals half its arc. So the arc from here to here must be double a 90-degree or right angle, which means this arc must be
A semicircle?
180 or a semicircle. So if it were to join the endpoints here, this would have to be a diameter. And that's the principle. Any angle inscribed in a semicircle is a right angle, so any right angle inscribed in a circle gives you a semicircle, right? And so, I mean, that would be true, right? If I took the compass, actually drew a real circle, drew some random chord, and put a perpendicular at one end, joining the endpoints would always give me a perfect diameter. That's actually one of the principles of the right angle rule that a carpenter would use. Okay, so if this is a diameter from 10, 0 to 0, negative 6, I can use that information to find the equation of the circle.
You would need to find a midpoint to get the center. That would be 5, negative 3. And then you would need to find the radius. 25 plus 9 is 34, square root of 34. So
Good, so what's the equation of the circle?
X minus 5 squared plus y plus 3 squared equals 34.
Boom. And there we go. Of course, that's in your textbook as well, as you kind of follow it through there. But good, you did it without really referencing the textbook once we got the picture up here on the board. Does that make sense? So a little fact of geometry that I wanted to review with you there. It doesn't necessarily lead to another problem per se, but did want to go over it. Let's take a look now at number 7. And back to page 230. And what are we told about our circle or circles here?
Center on the y-axis, radius 5, x-intercept 3.
Okay, so center on the y-axis. Where, we don't know. But we know the circle passes through
x-intercept 3.
an x-intercept of 3. So 3, 0 is a point on the circle. My circle goes through this point, but the radius is 5 units. So I know the center cannot be here, correct? Because that would only have a radius of 3 units. I've got to make it go up, 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 up until the radius of this unknown point is 5. Or down, 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 and down until this radius is 5, correct? However, if this radius is 5 and this length here is 3, I know how far up, 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 up I've got to go. Or how far down, 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 down I got to go. How can I find that?
Pythagorean Theorem.
Pythagorean Theorem. And so what would I get for this vertical distance up or down that I'd have to move in order to place the center at just the right spot, get a perfect radius of 5 to go through my circle?
Square root of 34.
You're finding a leg, remember.
Oh, it's the leg, okay, so...
5 would have to be the hypotenuse in this case.
Right.
Angle. You said right, I said angle. It's fourth quarter. The jokes are just going to keep getting worse.
Yeah.
Maybe after spring break, I'll have some good ones for a little while until I get tired again.
It'll be 4?
It'll be 4, right? If we go up 4 units or down 4 units, either way, right, that's going to give me a perfect radius of 5 to hit this point. Or something like that, correct? So what's the equation of the circle? Now, I already know the radius is 5. What is this point right there?
4, wait, 3, 4?
No, 3, 4 would be over 3 up 4.
Oh.
What's this point?
Gosh. 0, 4?
0, 4, right? Over nothing up 4, or this point here would be
0, negative 4?
0, negative 4, correct? Either of these would be the center of the circle. The radius would have to be 5. So the equations of my circles would be what?
X minus 0 squared plus y minus plus minus 4 squared equals 5 or 25.
There we go, equals 25. Good. Makes sense?
Mm-hmm.
So just using some knowledge, in that case using a little trigonometry there. Let's take a look at number 11 and go and read that if you would.
Use the equation of a circle to find points on the line x plus y equals 2, each a distance of 5 from 0, 3.
All right, so we've got this line that they call x plus y equals 2. And we've got another point somewhere that's presumably not on the line. We've got some point, let's just put it here and call it 0, 3. And we want 2 points on this line that are a distance of 5. So apparently it's not a distance of 5 from the line for there to be 2 points that are. So maybe this is a distance of 5, and maybe this is a distance of 5. Well, if we were constructing this, right, find all points this given distance from this given point that lie on the line, what would I draw in a construction? I want a point here that's a distance of 5 from 0, 3, but there's got to be a second point on here that's also a distance of 5 from 0, 3. We have a given distance from a given point. What is the locus of points, a given distance from a given point? a circle having the given point as center and the given distance as radius, right? You're starting to look from this perspective. Okay, let's draw a circle through that point, and then from this I could draw another circle, or from this point I could draw the circle with the radius of 5, couldn't I? What would be the equation of the circle then, Jamie?
X minus 0 squared, y minus 3 squared equals 25.
There we go. This circle would show all points that are a distance of 5 from this point. And these 2 points have to also be in this line. So how would I find those 2 points that are both in that line and a distance of 5 from 0, 3? System of equations. X plus y equals 2. X squared plus y minus 3 squared equals 25. Take a moment there at your seat. Find the 2 points where the line and that circle locus come together. And Quentin is here, so he's only going to have to watch the first 31 minutes of this lesson. Jamie was missing you. She's having to answer everything all by her lonesome. I'm glad you're not sick.
Yeah, I just had an appointment.
Oh, doctor's appointment. Okay. All right. Well, you see, we were all concerned you were dead or dying or deathly ill because you never miss school. You still don't. Good to see you. We're solving this system of equations right here, Quentin. The problem asked, in this line, x plus y equals 2, whatever that line is, there are 2 points that are a distance of 5 units from another point, 0, 3. Well, we concluded if I were to draw a circle around point 0, 3 with a radius of 5, that would give me every single point this distance from this point, using the circle equation. So if I put that circle equation with the line equation as a system, I'll find the 2 points of intersection, if they exist. Presumably they do. If they don't, we come out with some imaginary answers, and then we know they don't exist. Jamie's got them. Quentin, you just started on it. Walk me through what we need to do to solve this system.
You would have to move y over as negative and plug in 2 minus y for the x.
Good. Let's plug in a 2 minus y here. So that means it's going to get squared to give me
4 minus 4y plus y squared. And then plus y squared minus 6y plus 9. Minus 25 equals 0.
Okay. Good. Keep going.
Define like terms, so 2y squared minus 10y minus 12. 0. Take a 2 out all of it. So y squared minus 5y minus 6 equals 0. And just backwards 4y positive negative 1 6. So y equals negative 1 2.
All right, so is that the point, negative 1, 6? No, those are both y values. So one of my points where my line intersects the circle is something, negative 1. The other one is something, 6. How do I figure out the something?
Plug the y back in one of the equations.
Right, we'd already rearranged this x equals 2 minus y. Plug in the negative 1 or plug in the 6. And what do we have to go with the 6, for instance?
Negative 4.
And with the negative 1,
3.
and there's my 2 points. Is that what you had, Jamie? Excellent. Questions on that? All right, let's take a look at one more, and that's problem number 5. We're on page 230, Quentin. Sorry, page 230. The directions for number 5 are up above this section of problems. Go ahead and read the directions and number 5.
Find the equation of the circle having given values. Center on x equals 3 and radius square root 13 and pass through 6, 5.
All right. So again, as a little sketch is probably going to be really helpful here. So let's draw a sketch of this. Start by drawing a sketch of the line x equals 3. All right, do you have that? All right, now the center, it says, is somewhere on here. The next thing it tells us is it has a radius of?
Square root of 13.
Well, that's not particularly helpful, because I could still draw the circle anywhere, but that kind of sets the size of the circle, doesn't it? So square root of 13, that's a little bit bigger than 3, isn't it? So that means my circle is going to extend just a little beyond the y-axis. So it's going to be a circle about this size, but I still don't know quite where to put it, correct? The final information is that it passes through 6, 5. So if this is my point 6, 5, my circle is going to be about this. Well, it's got a defined radius. Is that a distance of square root of 13? Direct straight line distance? No, that's also a distance from 3 to the 6. It's also a distance of 3. So my circle can't just go straight across. My circle has a radius a little bigger than that. So it's going to have to be something like this, perhaps. Or if the center were up a little higher, it could do something like this. Do you see there's two different circles that could have their center? One of the centers might be here. The other of the centers might be something like here. Either way, the radius is square root of 13. Or in this case, the radius is square root of 13, right? The question is, what's the center? Right, because in center radius form, right? X minus x1 squared plus y minus y1 squared equals r squared. I know one part of it. In fact, I technically know two parts of this. I know the x value is going to be what? 3, right? It's 3 something, and here is 3 something else, right? So I know it's going to be x minus 3 squared plus, I don't know what's going to go in here. Y plus or minus something, right? But I also know what goes at the end.
Square root of 13.
Squared.
13.
So just a 13. The question is, what is that point? Thoughts?
The square root of everything.
If we call this point 3y, and I know the distance is the square root of 13, and I know this point is 6, 5. This point could also be called 3y, by the way, so I don't have to do it twice. Just 3y generically shows it. I know the distance between those 2 points.
Use the distance formula.
Use the distance formula, yeah. So,
D equals the square root, changing x squared equals 13 squared.
Jamie's like, it's his turn to answer. I'm just going to be quiet and sit here because it's his turn. I mean, I know the answer already. I already solved it in my head, but I'm going to let him answer. All right, so Quentin, what is the D? Square root of 13. What is the change in x? 3 squared. What's the change in y?
Y. 5 minus y.
Right, 5 minus y, just as 3 or 6 minus 3 is the change in x. 5 minus y or y minus 5, either way is fine, is going to be my change in y. Take it from here.
Square root of 9 and then 107. Square root of 9 plus y squared minus 10 y plus 25.
Okay, he couldn't handle the 5 minus y. He had to reverse it. That's fine.
Add like terms, so y squared minus 10 y. 34. You can take the square root of y squared.
That's a term. We would need factors if we try to do that.
Backwards form.
Jamie?
Square root of size.
Get rid of these radicals, right? We could have done that technically at the outset. Let's get rid of the radicals to get what now, Quentin?
13 equals y squared minus 2y equals 34.
Doesn't that just look better without the radical? It just feels so much better. All right, keep going.
Move the 13 over as a negative.
Good, set it equal to 0.
And plus 20. And backwards 4. So y negative 3 and 7.
So what are my y values? We said this is 3 something, this is 3 something else. Well, one of them is 3, and the other is 3, 7. So the equation of my circle could be x minus 3 squared plus
Y minus 3 squared.
equals 13. Or the equation of my circle could be
X minus 3 squared plus y minus 7 squared equals something.
not just something,
13.
square root of 13 squared, or 13. And there's 2 separate circles equations. And Jamie's like, yep, that's what I had. Questions on this? Questions on this? All right, well, we will delve into some different sides of things with circles in our next lesson, but no homework for this evening, and we'll resume on Friday for our next lesson. And then, of course, after that, we'll have spring break. So if you're watching on YouTube, take several lessons off once we get through our next lesson. All right, have a wonderful rest of your day. When the bell rings, you'll be dismissed.